The slope of a line really is a measure of the steepness of a line when compared to the angle that the line makes with the x-axis. That's one definition. There's another definition which we're going to look at in a minute, which involves the coordinates of two of the points on that line, which is a little bit easier for us to deal with at this particular point. What you see in front of you are a number of different lines. The black lines have positive slope. The red lines have a negative slope. And the blue line has a slope of 0. For the black lines, as you move from left to right, the y values get larger. For the red lines, as you move from left to right, down the line, the y values get smaller. And for the blue line, as you move from left to right, notice that the y values don't change at all. The y values are always the same. And that particular line has a slope of 0. Let's take a look at the definition of slope when I know two of the points that are on a line. So for example, if I have x1, y1 and x2, y2, those are the coordinates of, that's the first point and the second point. If I have those 2 points, by the way, you don't have to have this picture. You can just simply have the coordinates of 2 points that you know that lie on a line. So given those 2 points, right, x1, y1 and x2, y2, we define the slope to be y1 minus y2 divided by x1 minus x2. And we usually use the letter m when we talk about slope. Let's take a look at this in action. So for this line, if I'm able to identify 2 of the points as 0, 2, and 3, 4, and I can calculate the slope by plugging in the y values, the difference of the 2 y values, divided by the difference of the 2 x values. Notice I get 4 minus 2, y1 is 4, y2 is 2, and 3 minus 0, x1 is 3, and x2 is 0. So I wind up with 2/3. This particular line has a slope of 2/3. At the bottom here, you have an interesting statement, which is a statement that's true all the time for any line. The slope of a line is constant. So even though I selected those 2 points, if I knew of 2 other points on the line, I would wind up with exactly the same answer. The slope would be 2/3. Let's take a look at the concept of rise over run quickly. If I start at the point 0, 2, the bottom point, which is really the second point, and I want to wind up at the point 3, 4, what I'm going to first do is I'm going to draw a line that is parallel to the x-axis, and I'm going to stop under the point 3, 4. And notice since I moved to the right 3 units, okay, that's the change in y, okay? And I'm sorry, the change in x. Since I'm moving to the right 3 units, that is the change in x, which turns out to be this right here, x1 minus x2. And then from this point right here, in order to get myself up to that point 3, 4, notice the arrows, I'm moving up, and that's 2 units. And now those 2 units are actually the change in y. So that right here is this right here, okay? The rise is 2. That's how much we rise, which is really the change in y, okay? And the run is 3 units, positive 3 units, which is the change in x. So I wind up with 2/3. Let's take a look at a line that has a negative slope. All right, here's a line that has a negative slope. Turns out it has a negative slope. What I want to do is I want to find the slope of the line that passes through the points -1, 3, and 3, -2. Doesn't matter which point is the first point or the second point. Okay. Applying my slope formula, y1, right here, -2 minus y2. y2 is 3. You've got to be very careful with your signs here. Okay. And -2 subtract 3 is -5. And then on the bottom we have x1, which is 3, right here. and then we're going to subtract x2. x2 is -1. Okay, so that would be 3 take away -1. 3 take away -1 is 3 plus 1, which is 4. So really, the slope of this line is -5 over 4, and we can really write that as -5/4. Let's take a look at rise over run and see how I wind up with a -5/4. So if I were to start at the point -1, 3, right here, and I wanted to move to the point 3, -2, right here, I would first go down parallel to the y-axis until I got to a point which is right across from the point 3, -2, and then I would move to the right. Notice the arrow moved to the right until I actually got to the point 3, -2. So going down, that first motion going down, the rise would be 1, 2, 3, 4, 5, and since I'm going down, it would be -5. So that's why rise is -5. Now, once I get to this point, I want to move to the right to 3, -2. I'm moving 1, 2, 3, 4 units, and since I'm moving to the right, okay, the run would be +4. So that's the rise over the run. And the slope of this line, again, as we saw before, was -1.25. So we've seen a positive slope and we've seen a negative slope. Let's take a look at a horizontal line and take a look at that. All right, here's a horizontal line, which is parallel 1 unit above the x-axis. For those of you who want to know what the equation of it is, that is y = 1. I'm not so concerned about equations. I just want to deal with the points right now. If I plug the x1, y1, and x2, y2 into the slope formula, what I do is I wind up with 1 minus 1 on the top, and on the bottom I wind up with 2 minus -2, which turns out to be 4. 0 divided by 4 is 0. Okay. What you could have done is you could have subtracted those in the opposite direction. In either case, in the top we would have 1 minus 1, and on the bottom we could have -2 minus 2. So if I had 1 minus 1 over -2 minus 2, that would still be 0 divided by -4, because -2 minus 2 would be -4, so that really would be equal to 0. It doesn't really matter what order we do that in. All horizontal lines have a slope of 0. It doesn't matter where you put the horizontal line. As we move from left to right, there is no change at all in y. X obviously changes, but the important thing is that the change in y, there is none. It's actually 0. So horizontal lines have a slope of 0. Let's take a look at vertical lines. As far as the slope of a vertical line, I've drawn a vertical line in here, and I found 2 points that are on the line. You could select any 2 points that you want. -2, 3 and -2, 1. I've plugged them into my formula, and I wind up with 3 minus 1. So this point would be the first point, -2, 3. And on the bottom, I get x1 minus x2, which is -2 subtract -2 on the bottom. So 3 minus 1 is 2. -2 subtract -2 is really -2 plus 2, which is really 0. And as we learned some time ago, whenever we don't want to we can't divide by 0, a non-zero number divided by 0 is undefined. The fraction itself is undefined. So I can't figure out what the slope is. Okay? And so all vertical lines, doesn't matter where you put it on the coordinate axes, have a slope that is undefined. Horizontal lines have a slope that's 0. Vertical lines that go up and down have a slope that's undefined. A little bit of information about the slopes of lines.